My name is Niran Chan. This is Mitesh Panchuli.
Good afternoon.
And welcome to Automating NSX for virtual machine and containerized applications. Before we begin, take a few seconds to read the disclaimer. Everybody read it? Yeah? Good. So we're going to start with an overview a bit about the cloud native applications at VMware. And then Mitesh will go into automating NSX with VRA and a cool demo about that. And then I'm going to touch on PCF and NSX and a bit about Kubernetes and NSX. And just a small disclaimer for myself and Mitesh. Obviously, we can't cover everything here, but we can direct you also to additional sessions for additional in-depth about the different subjects we're talking about. Make sense? Good. Mitesh,
Great.
take it away.
Thank you, Niran. So just to give you guys a background, right? Both Niran and me live and breathe NSX day to day. Niran is a specialist in our team for sure in VMware, and is one of the guys I go to when I get in trouble. And when I get in trouble, there's really stuff happening. I work in the professional services team, so when you buy our software and you're deploying and something comes up and you need professional services help, we show up, right? And then when we need help, we go to these guys. So let's have a quick show of hands. How many folks here have NSX deployed in their environment right now, either test, dev, or production? Wonderful. Now keep your hands up if you're doing integration with NSX and VRA. Wonderful. Wow, that's a significant amount of folks. And how about folks who are thinking about doing NSX and containerized applications? Wonderful. Yeah, similar number of people were thinking about it. Cool. Awesome. Great. So we'll definitely cover a lot of that, breadth. What you should think about when you think about, at least the CMP, which is what we're calling our cloud management platform, right? The VRA as well as VIO. There's also CodeStream in the back if you want to start doing CI/CD. What you should think about is a lot of that rests on basically our SDDC architecture, which is vCloud Foundation, right? VCF. It's NSX, vSAN, as well as vCenter, right? So a lot of the benefits that you get out of vCenter are out of the box that you can start integrating NSX with. How many folks here have started using vCenter specifically with VRO, vRealize Orchestrator? Wonderful. That's about 23% of you or so. And if you haven't started using it, please do use it. VRO, specifically Orchestrator, is a free product. If you have a vCenter license, you get VRO for free. And we've been running it for the last 16 years or so, and it has a whole bunch of workflows and scripts ready to go for you to use. And in our demo, we will show you how cool it is to use it with VRA, so that way a lot of the second-day operations that you have to do, you don't have to take care of them anymore. VRO can do them for you. Right?
Yeah, it's the best product we've never sold.
That's right. Okay. So then in terms of, let's have a show of hands. How many folks here are supporting networking operations in dev, test, and prod, right? When somebody says, hey, I want to open up a firewall port or SSH. Great. Many of you. I think that's like a 33%, 34%. Okay. So we'll show you how VRA and VRO can help you there. Beyond that, specifically in terms of how vRealize integration with NSX works, is pretty straightforward. For those who are using VRA, you could see that really clear, beautiful UI that we have. It plunges into our unified service catalog with our converged blueprint. And then that basically does a lot of the back end with our connectivity and availability and security behind the scenes. And I'm sorry if I'm going a little slow. I had too many tapas 2-3 days ago, and I was laid out flat yesterday. So I think I'm still recovering from it. The benefits of that basically is obviously, a lot of service delivery is unified. There's a lot of app-centric networking and security. And I also want to say that to the workload. So if you have a virtual machine and you need to be able to control what actions can be taken on it from a networking perspective, you can do that through VRA, right? Rather than having somebody open a ServiceNow ticket that eventually gets to you, and then you talk to the security team, and then they make changes in NSX, and then you come back and the customer's like, dude, I said that 5 days ago. Why hasn't it happened yet, right? Whereas with VRA, you can enable them to do it themselves. And because of that, the wait time for IT services is significantly reduced. And the best part of this is you can manage all this as infrastructure as code, right? So you can create a blueprint, you can create a couple of actions, you can create all these associations, get them in a JSON file, plunk that into a Git repository and say that's our golden blueprint basically. And as weeks go on, if you want to make changes, you make changes to the code, and then VRA can start consuming those changes quickly and easily. And, you can migrate them between your dev, test, and prod relatively straightforwardly, especially if you use a product that we produce called Houdini. How many folks here have used VRA in Houdini? Okay, great. That's a new session that I would definitely recommend you go to. Houdini lets you take all the configurations of their entire SDDC stack from dev and get them up into a JSON-enabled file, basically, and then push them down to production or test, right? So that way you can migrate configurations around that are all VMware related. Wouldn't that be cool? Well, we already do it, so you should be able to use it. Okay, so then beyond that, in terms of the use cases that we see for VRA and NSX specifically, it's first for network admins, folks like you in the team, right, where you're fielding the questions from ServiceNow, you're fielding the questions from all the CMDB tickets that you're getting saying, open up port 22 for me on this particular machine for SSH, or open up port 5806 for doing the appliance configuration on VRA, or a number of these other questions, right? Or go ahead and map this network with this particular virtual machine, right? Am I missing a use case here? Or raise your hand if you think I'm covering majority of what you do day to day from an NSX perspective. Wonderful. So I see I'm talking to the right audience here. So basically the network admins, the security admins, and the developers as the consumers, they can all start using vRealize automation NSX, so that way they can start managing the workloads, they can make changes to the virtual network infrastructure, and then beyond that, NSX will wrap the physical network infrastructure, so they'll never be bothering you or the actual physical team that's needed, right? So then in terms of how does this actually work, well, there's a lot of complexity on this side, right? In terms of how VMs are mapped to particular networks, how the east-west routing occurs, how that gets plugged into, a northwest router on the NSX edge, and then how we're doing that with multi-tier, and how we're enabling that on a multi-tenant service-enabled providers, right? So that way, if you have a Coke or a Pepsi model where, you have one customer that can't look at the data as well as traffic from another, how do you manage that in VRA? Well, we could definitely do that using multi-tenancy that's inbuilt. So with that said, I think, we'll talk a little bit about the security operations, but the main thing for you to look at is the demo, right? Because the demo is going to cover a lot of the material that we want to show from an NSX perspective with VRA integrations. The operational model is pretty straightforward, which is, the network admin defines what the fabric of the network should be like. So for example, what the network profiles are, what the balances are that we're going to go to, what are the network externals that we're going to go ahead and work with, right? As well as what the fabric looks like for the VRA layer. The other thing the network admin also does, which we haven't laid out here, is they associate what network fabric gets associated with the business group. Because with VRA, using especially business groups, you can do multi-tenancy. So that way, if Niran is coming from the Coke side of the tenancy, he can see a whole bunch of networks that I might not be able to see. And if I'm coming from the Pepsi side of the house, he might not be able to see the same networks that I am, right? So that way we can start doing multi-tenancy and segregation at the network layer rather than just at the business group layer. Beyond that, there's a security admin. The security admin defines the security tags and the groups and the policies. We'll get into the groups in a quick second when we start kicking off the demo. But basically, they're the ones who are, managing the distributed firewalls and security groups and policies. The cloud architect basically, comes in and builds the blueprint and starts associating what the blueprint looks like with the security groups as well as the tags, and then what are the network profiles that are being consumed. So this is the first person where all of these different modes of operations, right? Networking, storage, CPU, blueprints, right? RHEL, Windows, all these other things start coming together. And that's this person, cloud architect. And they also consume a lot of the business groups that are defined by the VRA admin. I haven't got that up on the slide deck, but it's implied. And why are we doing all this wonderful work? Well, it's for the benefit of this person, right? The cloud consumer. All they care about is they want to get up there and say, I want to deploy an application, or I want to make changes to a network, or I want to add a network to a virtual machine, or I want to go ahead and change a firewall port so that way I can go ahead and start routing traffic to my applications or virtual machines, right? So all of those things, they can do themselves, self-service. We want to eliminate that path so that way you get back that time of the day that you can work on new work, right? So that way you can also define it once and get it running all the time without having to bring you in every 15 to 20 minutes saying, hey, Niran, you changed the wrong port. Now go ahead and make a change for me, right? So we'll get into that in the demo in just a quick sec.
Yeah, and just a quick question to the group here. How many of you seen those 3 roles in your organization consolidated in one person? So, not a lot. Oh, okay, about 10%.
Yeah. But it's happening, because as infrastructure is becoming code, a lot of these layers are collapsing very quickly. And at many of our biggest customers, we've seen exactly what Niran is talking about, which is one person is put in charge of these 3 operations. Now imagine being put in charge of that and having to deal with customer requirements saying, open up port 22, close port 3306 for MySQL, blah, blah, blah.
Exactly. And one person, one group, right?
That's right. So we want to help you, we want to enable you when this actually occurs to be able to be more productive, and that's what the demo will talk about. Okay, so with that said, yeah, we've talked about this already. Let's go. The other automation NSX use case, is basically so that way we can, get into the self-service that we talked about. And with that said, I think we're going to go into the demo. Okay, so just as this is going to be a recorded demo, because just as we predicted, the Wi-Fi is not as strong as we wanted it to be here. So access to our lab is going to suffer significantly. So let me see if I can turn that on. First of all, I should apologize. This is a recorded demo, but better recorded demo than not a demo.
Yeah,
right?
That's for sure.
Exactly. So what you see here is, our traditional vRealize automation UI for doing self-service. What's on here is the Ubuntu server that I've gone ahead and defined a blueprint for, as well as a Windows 2K16 server, right? Pretty straightforward. This is the view that a consumer of your VRA self-service portal will see. They can come in here and click request, and that'll kick off a virtual machine workload build for them, right? It'll do all the stitching behind the scenes with IPAM. It'll go ahead and talk to AD. It'll go ahead or LDAP. It'll go ahead and talk to vCenter. Go ahead and cut the virtual machine. It'll talk to NSX, and I'll show you where that actually occurs. And then once the virtual machine has been produced, we will start attaching second-day operations, such as make a firewall change port for me, right? Or go ahead and attach a new network, right? Pretty straightforward. So, that's the UI that you should see. Raise your hand if you've seen this UI before from VRA, and this looks familiar. Wonderful. A lot of you have already, so that's perfect. And just so you know that I'm not pulling any punches here, this is the way that you go around and declare a request a virtual machine. And as you see in my items and requests tab, that virtual machine is being kicked off, right? Which is Ubuntu 16. And when that virtual machine gets kicked off, I'll pause here for just a second. What you'll see ends up happening is I end up getting a lockdown version of Linux, right? As well as access to a particular group of network, as well as some security groups that are attached to it, right? So all of these wonderful ideas about which network, which security group, which blueprint, which ISO, right, which IP address, all of that gets sucked into one thing, which is our composite blueprint, right? That's here. So I just did that to show you that, it actually works, and I'm going to skip through some of the more boring parts, which is when VRA is actually doing it. Well, how do you do it, right? I get that from customers all the time. Well, when you're defining a blueprint, for example, right now, I'm editing this blueprint for Ubuntu 16. As you can see, I can drag and drop different things on here, including machine types, other blueprints, other X as a service. And what are X as a service? Well, F5 as a service is a very popular service for us. So you can make a service that says, go ahead and add this virtual machine to a particular VIP, right? Or go ahead and create a brand new VIP for a particular virtual machine. Beyond that, you could also go ahead and add machine types like our EC2 machine type. So that way VRA can talk to AWS and get you a virtual machine on EC2 and then manage it locally. There's no NSX integration yet, but it's coming down the pipe, and we can definitely talk about that a little later. So then beyond that, what I think I'm going to show you guys is, when this gets defined, I can also start attaching things like, hey, I want to go ahead and start attaching a security group, right? So when I go into my build info and the machine resources, you can see, I'll define something very specific like how many CPUs can I have minimum, maximum, what is the memory, what is the storage, and then I can drag and drop them in there as needed, and then what is the network, right? So these are the networks that are exposed to this particular tenant. Now, I want you to keep that in mind. In VRA, you can't see all of the networks that are there unless they've been provided to you by the business group that you're part of, right? So if you're part of the Mercedes-Benz business group, you will get one particular part of the network segment that your VRA administrator defines. Whereas if you're the Volkswagen part of the business group, which I'm always part of, I always get the cheap stuff, he gets the good stuff, then you get a second type of network, right? So that way the network and the traffic are not commingling. So that's why you're only seeing one network there. But in production, if you're doing a lot more networks, you could definitely expose that to them. So as you can see, I'm just dragging and dropping things on there and building my profile, which is pretty straightforward. And I'm going to keep going a little bit further to go ahead and add a few security groups. So as you can see, what I did is basically I went in and I said, hey, I want to go ahead and add in a particular security group called Linux Lockdown Security Group. And what that is doing, just to set the stage, is it's setting up port 80 as open and setting up port 22 as filtered, so that way we can control access. And you know that I'm not lying to you in just a few minutes or just a few seconds when I start running ZenMap. So that way we'll start scanning the ports and seeing what's actually happening, right? So we'll drag and drop this guy on there as a security group, and then configure the machine appropriately. There we go. And then when I kick it off, here we go. Here's the ZenMap scan of it. My virtual machine has been deployed, and as you can see, port 80 TCP is open, port 22 has been filtered, right? And that's ZenMap saying. Well, if I try to do it myself, let me just show you. I'm going to skip over some of this stuff here. There you go. That's the problem with a recorded demo, I guess, right? That I can go there using my port 80. I'm going to show you that. But then I can't pause it correctly. There it is, Linux 002, Nginx is running. And then when I go back and check the IP and try to ping it or try to SSH it, you saw that I wasn't able to get into that, right? Pretty straightforward. So how does this actually happen behind the scenes, right? All we did is we deployed a virtual machine, we attached it to a network, and then the networking security policies kicked in and the security group kicked in, and we started to do the appropriate port locking as well as network mapping. Well, this happens because on our side, we have something called the NSX Service Composer. And in the Service Composer, you can basically go ahead and start defining these security groups. That's where I got the security group implemented into VRA from. As you can see, there's the lockdown Linux server. And if I go into the details of that, you'll see it has a single security policy over here, right? There's one single security policy, and all it does is allows for either inbound or outbound SSH. So that way I can lock down the traffic coming in and out at the NSX layer. And then whatever I do at the NSX layer gets deployed out into VRA, and then Niran will talk about how that actually impacts on the other side of the house, which is Kubernetes as well as PCF, right? So once I've gone ahead and done the deployment of security groups, and before I go into a little bit more, raise your hand if you've worked with security groups on NSX in the past year. Great. So you know what this UI looks like. In NSXT, we've been talking about being able to do this automatically so that we don't have to go through the UI all the time, which would be a big benefit for folks who are doing infrastructure as code. So as you can see, I've gone ahead and made my security change, and then when I go ahead and ping that Linux 002 virtual machine again, my TCP port basically got opened again, right? I had to do 0 operations on the VRA side. I had to do 0 operations on the virtual machine side. It just happened because I made the change on NSX. So that's you doing the change, right? The network administrator. How does this work when an end user wants to do the change? Because we don't want to put you as the bottleneck, right? Because you'll get 1,000 requests for port 22. Well, here's how you do it, right? And I'm going to breeze through it so that way I also give Niran an appropriate amount of time. What you do basically is you go ahead and create a brand new resource action, right? As you see here, in my vRealize automation, I'm in the Design tab. In the Design tab, there's a Resource Action tab, and you get a few default resource actions such as stop, start, restart, manage IP address, or delete. These are stock virtual machine resource actions. But then I can also add a new one, and I'm going to add a new one called Open Up Port 22, for example. Now, VRA is smart enough to know that if you're dealing with a virtual machine, here are the NSX, or here are the resource actions as you're allowed, like snapshot, like start, stop, or change the RAM. Whereas if you're dealing with NSX, you might have other resource actions like, hey, go ahead and create me a brand new IP in that particular subnet, or go ahead and make any type of changes that we want to the firewall. So this is going to be just a quick, brief demo on the VRA side of the house, which is I'm creating a brand new action. Now, what are actions backed by? Well, resource actions essentially backed by VMware VRO workflows, right? I'm in the vRealize orchestrator, and within that I have a simple workflow called add VM to security group. And what it does is pretty straightforward. It goes ahead and fetches the virtual machine using the managed object reference here. And then it goes ahead and runs this little script, and all it does is it adds the virtual machine to the security group that we've defined for port 22, right? Straightforward. Now, once you've done that, what will end up happening is VRA will consume this particular workflow and attach it to the blueprint that we want. And then every virtual machine that we've created using that blueprint will get that resource action. So a particular customer can go in and say, kick off this virtual machine, and then go ahead and make that change. So that way, once the virtual machine is live, I want to make it changes to port 22, and it'll work appropriately, right? And how does that work in the UI? Well, let me just show you, right? I go back in and I add the resource group. I can go ahead and add a UI element like a checkbox or an image or something like that if I want to, but I'm going to skip that. And then basically I'm enabling the resource action here. So when I come into the user and I say I want to go ahead and add port 22, you can see the UI here is my VRA UI. Pretty straightforward, my Linux virtual machine right there. And then in the Actions tab, bam, there it is. You see that? Request SSH access. That's it. So a little bit of work there will save you hours and hours of work later on, right? Because now the end user is doing this. You're not even involved. All you were involved in was what Niran mentioned in terms of that collapsing, where you had to go and define the security groups, you had to go and define some of the networking practices, and you expose them in NSX. Your VRA administrator consumed them and exposed them to the customer using request SSH access. And then because of that, the customer was able to go in and just click that. And when they clicked it, it becomes essentially an approval process if you want it to be. Or in some cases, it becomes an instantaneous change. So what we've seen at our customers is for dev and test, they'll make the change instantly. But if it's a prod environment, they'll say, we want to put in a brand new particular approval process in the middle. And how do you know that I'm not lying to you? Well, you can see that I went ahead and made a request for change for SSH. And then behind the scene, what was happening is VRA was talking to VRO. VRO workflows were kicked off. That VRO workflow kicked off and went ahead and made the change to the security group that we wanted. And then if you go back to Nmap, you'll see that this will go ahead and go from filtered back to open. So that way, we can go ahead and see that the SSH worked correctly. Let me just make sure I show you that. Yep, so there it is, and then we're doing that, bam, right there. See? So that should have shown you, team, in terms of, what the end-to-end VRA to NSX integration looks like. I'm going to flip back to our presentation here and hand it off to Niran. But now you should have a pretty good idea about how VRA, NSX work together to enable a lot of your day-to-day networking operations in an automatic way. So that way you yourself are not becoming the bottleneck and you can empower your end users to do it. Thank you for your time, and I think we'll switch to Niran before we get to any other questions.
I'm trying to get this out.
Control P. Windows P, sorry. Extend, yep. Is there an engineer in the house who could help us? Oh, no, you got to present.
Oh.
Let me do it. There we go.
Yeah, all right. And just very good demo. Thanks, Mitesh. And I must say, this is just a small use case of adding, a single rule in firewall. There's a lot you can do. VRA is very customizable, and these blueprints can create many, many different services and actions that can be requested through the CMP. And I want to switch gears now from a cloud management platform solution like VRA, which is a more involved kind of process, to containerized platform like PCF, Pivotal Cloud Foundry, and Kubernetes, where we actually seek a less involved process in automating NSX. The idea on those platforms, and I'll go through PCF a bit, and that will give you also an idea about Kubernetes, you probably have it also, is that we want to focus on code, and we want everything else to happen automatically in the back end. And I usually say NSX now becomes to be like the carburetor in a car. You actually don't need to touch it too much, and things just happen for you. Now, before I go ahead, I just want to see, we raise hand in the audience here. How many people know what Pivotal Cloud Foundry is, PCF? Raise your hands. Right, not a lot. So I'll go over that as well. And Kubernetes? People know a bit what Kubernetes is? Okay, good. So, where's the clicker? So, PCF is a PaaS platform as a service, which provides automation capabilities for infrastructure and orchestration of containers. The idea is that everything happens, the developer can focus only on the code, and the platform take care of everything else. It's a very opinionated system, and customers love that because they can actually focus on what they do the best, which is write code. They don't need to take care of a lot of things. So I'll go through a short workflow, a process here, just to understand what PCF is. So we've got a developer, and this is kind of the pivotal haiku. Here's my source code, run it in the cloud for me, I don't care how. And this is actually true, because source code, almost any language, you can get it and drop it on PCF, and PCF will take care of the rest. So we have a developer that writes a code, and it kicks off to Git, checks out to Git, in this case Git, right? And that would kick off a pipeline. With PCF, in many cases, we're talking about a solution from Pivotal called Concourse, but can be other pipeline managers, obviously, that basically runs pipeline, meaning it's a process, a series of steps that you don't deviate from, right? It just runs through a series of steps for you. And what it will do is it will create an artifact. In this case, on the screen is a WAR file, it's a Java, right? But it can be a lot of other things. The code basically turns into an artifact that we can containerize out. So once we push it, and you see, in order to deploy the application, you just need to run a single command called cfpush. And to be honest, when we talk about CI/CD, continuous development, the developer doesn't even do that. Just kick off the pipeline runs through this, and we'll push it to several maybe platforms just to run the application. So once it pushes it, the WAR file gets deployed into PCF, into an area called the staging area. And in the staging area, the PCF will detect exactly which root file system it needs, which is kind of the root file system for the container, and the build pack. The build pack would be the runtime for Java, for example, that needs to run the artifact. And it will detect the right build pack that it needs, and will combine them into an image, a container image that's called a droplet. And this is kind of you can compare that with a Docker image, right? A droplet is just a different type of container. But in this case, it's a droplet in the case here. And once it creates that droplet, it will deploy that into Pivotal Cloud Foundry to run. And in Pivotal Cloud Foundry, there's a notion that's called availability zones. So if it's on vSphere, that would be separate clusters, for example. And we'll deploy those application images into those availability zones. So it took care of our availability requirements. It took the code, it containerized it for us. And as a PaaS does, and you'll see what Pivotal does, it also can connect it to additional services that might be required that the developer doesn't need to take care of. If I want to connect to a MySQL database, for example, all I need to do is declare that in the manifest, and Pivotal Cloud Foundry will take care of that for us. The idea, again, PaaS, the platform takes care of everything for us. So this is our application. Even though we have multiple application instances, it's a single application with a single URL. And it's going to get published into the load balancer, in our case, NSX Edge. And the routing would go through internal routing constructs in PCF, which are called Go routers, or PCF routing in our case. So when the user goes and tries to access the application, it gets routed through and reaches the application. If it's a Docker image, you can do the same. Basically, you take the Docker image, you deploy it to PCF, and it's going to get run. And you can see on the bottom, again, take my code, any code, run it on the cloud, I don't care how. Okay, that makes sense, kind of a 101, what is Pivotal Cloud Foundry. So when it comes to NSX, at the moment, NSX that works with PCF is NSX-V, NSX for vSphere. When I talk about Kubernetes in a second, I'm going to touch on Kubernetes. I'm not going to go too deep, but basically that's NSX-T. So right now it's NSX-V. In order to understand how NSX automates for PCF, to be able to be consumed by PCF, just need to understand a bit the architecture of the system. So we got what's called the PCF Foundation. And we got the control plane on the foundation, which has two components. The first one is called Ops Manager, Operations Manager. And Operations Manager, it's what differentiates, one of the things that differentiates Pivotal Cloud Foundry from the open source Cloud Foundry. And Operations Manager, basically, I like to make kind of the comparison, even though sometimes people might say not exactly it, but kind of the NSX manager of Pivotal Cloud Foundry. Okay, it deploys additional components. It provides an API access. It provides a UI access for the users. Right, when I do CF push, it goes through that. The second component, which is hugely important, it's called BOSH. And BOSH is a component that does automation on the infrastructure. And basically, it does a lot of other things that are regarding day two operations. And day two is a lot of the things that Pivotal Cloud Foundry are known for. So if I want to, let's say, upgrade my platform, it can go and basically switch out all the components underneath with no downtime. If it sees that the VM having problems, it can kill it, shoot it in the head, and just bring up a new one. That's what BOSH does. And it communicates with the underlying infrastructure by something called a plugin, a CPI, Cloud Provider Integration interface, and basically that talks with, let's say, vSphere or Amazon or Google or whatever. The second component, which is the important component here, it's called ERT. And that is comparable to, let's say, Kubernetes. That is the container orchestration tool that basically orchestrates containers or application instances within Pivotal Cloud Foundry. Two of the main components of that are the Diego cells. Those are virtual machines where the application instances gets deployed on. And we got the Go routers, which I mentioned already, which provide access to the applications that we're deploying. So the majority of virtual machines and networking is going to happen here. So when we look at, like, let's say, the NSX reference architecture for Pivotal Cloud Foundry, that would require /22 CI/CD/R just because the amount of VMs that resides on this component. An additional component in PCF, and this is the PaaS part, one of the biggest PaaS part of PCF are the services. So if I need access to a service, whether it's a database, authentication service, cloud services, I deploy that as something called a tile, and I declare that in the application, so the application automatically connects to that. So I create those services on PCF. Something that being worked on right now is, for example, Microsoft and Pivotal are working on a Microsoft SQL version for PCF to be deployed as a service, for example. And the last thing that I want to mention regarding the architecture of PCF is called isolation segments. So if I want to isolate some applications to a separate set of infrastructure and a separate set of security configuration, I can create isolation segments. It acts like as a side ERT just for those applications that I want to isolate for different purposes, let's say compliance. Now let's go and see what NSX does here. The first thing that NSX will provide us here is logical networks. The NSX, and based on the reference architecture and the automation we create, NSX will go and create a logical network for the control plane, a logical network for the ERT, the container deployment, and logical networks for the services. And any additional isolation segments will also get their own logical networks. So NSX that provides that. Obviously, if we want to communicate, and we do, between those logical networks, we need routing. So the second thing that NSX would provide is logical routing. In our case, we're talking about distributed logical router, obviously, which would provide routing from within the hypervisor between those networks. And we got the edge servers that provides multiple things for us. It provides on-off ramp from the logical networking that PCF requires, so access in and out. It allows us to create NAT constructs on it. So if I can NAT PCF, and you'll see also in Kubernetes, for example, I can add it. I can deploy multiple PCF foundations or platforms with overlapping IPs. That makes it much easier for me, because when we go PCF, you can see that we're talking about a handsome number of VMs. So those requires their own IPs and requires their own security and load balancing stuff. When I can NAT the whole thing, it makes it much easier for me just deploy it over and over again with overlapping IPs, all NATed out. And one of the main things that it does is provide us the load balancing. Okay, so I don't need to go and create work with my physical load balancers. I can have my NSX do the load balancing for me, and it's programmatically controlled. So you'll see that the day 2 operations that right now we get with PCF and NSX is actually auto-scaling into the load balancer using security groups that Mitesh mentioned with no human touch. And I'll show that in a second. And obviously we can do also firewalling if we want to on and off from the platform. So regarding automation for PCF right now with NSXV, first and foremost, we got the day 1 automation. When we look at Pivotal Cloud Foundry as a platform to deploy, the amount of virtual machines that are required and the amount of networking and security that I need to define, we're talking about a good amount of time to go and deploy a new platform, from conception to actually deploying it. One of our customers that I spoke with, he told me that when he goes to the security team and tells them, or networking team, and tells them that he needs this amount of IPs for Pivotal Cloud Foundry, they think is high. That's basically the word he used. So using NSX really helped there. But automating the whole thing takes it even one step further. So we got Concourse in this case, which we use. If you go and Google NSX Pivotal Cloud Foundry pipeline, you'll see it on Git open there. You can take the Concourse pipeline and actually run it in your environment and deploy PCF NSX in your lab. So we take Concourse, it runs the pipeline, and this is a view of how the pipeline looks. The series of steps that are green in this case, and interestingly enough, it's green many times because it's all logical. It makes it much easier. That communicates with vCenter that goes and deploys Ops Manager. And Ops Manager goes and deploys BOSH. And then once BOSH is deployed, it talks with NSX and deploys all the NSX constructs and then deploys all PCF on top of that. So basically we deployed A to Z, the whole Pivotal Cloud Foundry, no human touch. The only thing we had to do is just set up a few parameters in parameter file and have clusters and NSX, the clusters ready for NSX. And basically, the Concourse pipeline will go and create the networking constructs, create the logical networks, the DLR, the OSPF relationship between the DLR and the edge. Everything gets created automatically and then deploys PCF on top of that. And I can tell you, customers love that. It makes it much easier to go and deploy a foundation. And then what we can do is then we can create, we can deploy multiple foundations pretty easily. And day 1 operation, even though, sometimes customers can look at that as a single thing. So what if it takes me 6 to 8 weeks? When you think about it, people buy into those platforms to gain speed, to be able to do things faster. And that kind of disruption is not always the best thing for the process. Now, as I mentioned, many people go to Pivotal Cloud Foundry and BOSH because of day 2 operations. So we do have day 2 operations that are going on here. Introducing the latest version of Pivotal Cloud Foundry, actually, BOSH, when it goes and creates a new job, and let's say creating the Go routers is a job, it will go and create the security groups in NSX automatically. So a group for the Go routers. And will register the job with the security group. That means that every time I add a new Go router, I scale out the system, that Go router will automatically get added to the security group. So automatically you think, right, like Mitesh said, those can use both for firewall. But more importantly, right now, they can be used as members in a pool in the load balancer. So you can add, I don't know if you guys know, in NSX you can go into the load balancer and in the pool you add security groups instead of adding VMs. So when we do this, when we add to the pool, let's say the load balancers, we added the Go routers, then once we add new Go routers, they get added to the security groups, and the security groups get populated, and the load balancer expanded automatically. So from a day-to operations, we don't need to touch any load balancer to go and scale out the system. We scale out an application, we scale out Go routers, automatically gets added to the load balancer. Now from a firewalling perspective, obviously it also helps us with security, right? If I add new things to the security groups, if I create new VMs, for example, it automatically gets added to security groups and it helps me with the firewall. The only caveat here is that we're talking NSXV right now. And NSXV does not reach into the containers. NSXV on the firewall side and distributed firewall protects the virtual machines. So in that case, sometimes we might have a situation where we have multiple application instances from different applications running the same VM. It's kind of hard to do micro-segmentation with the distributed firewall. But it does help us with the isolation segments, which I mentioned. If you remember, look at the right, we got the isolated segment. We can actually protect those segments automatically using those security groups. So it does help us here. And expect to hear more things coming for PCF in the future to enhance into the container side. Let's see, what time is it? Okay, cool. Firewall. Animation. Nice. All right, now, before we finish this and go to questions, I want to also add the dimension of Kubernetes. And Kubernetes has a lot of interest and momentum in the market. The reason is, again, PCF is an amazing system, but it's very opinionated on how you develop into it, right? How you create code so that the system can take care of everything else for you. Kubernetes provides a container orchestration tool, but provides the ability to affect the process more. It's an open system. So Kubernetes and NSX provides the ability to do a lot of things, automated things, for the containers themselves. Obviously, we can do micro-segmentation for the containers, but I want to focus on the automation part of things. So the component of the integration between NSX and Kubernetes, the main component is called the CMP, the container, forgot the initials. Anyway, the CMP, the NCP. See, I'm excited seeing you guys. Anyway, the NCP basically is a plugin interface that we can add different adapters into it, and the adapters can integrate with different container orchestration tools. In this case, we're talking about Kubernetes, and also communicate with NSX Manager to automatically create the networking constructs that are required for our system. Again, as I mentioned, like a carburetor in the car, we don't need to do anything to make it work. It needs to work automatically, where the developers just do their developing stuff and networking just does its thing for them automatically. The process works in this way. We got the NCP, the NSX container plugin. You can see here on the left, the laser doesn't work. We got the Kubernetes adapter. That sits and listens to the API servers, okay, on Kubernetes. Creates a watch on it. And then when a user goes and creates something called the Kubernetes namespace, which is comparable to a tenant in our case, the Kubernetes API basically goes and talks with Kubernetes API talks with NCP, and then NCP goes and creates the networking constructs that are required. The way NSXT is deployed is we have the tier 0 routers that provides in and out access from the logical networks, and then for each namespace we want to deploy a new tier 1 router that acts as a tenant. So NSXT basically, the NCP will go and create a new subnet that will take from a pool that NSX manager provides. It will create a logical switch that you can see, and I'll show you in the next slide exactly the process, how it looks. And then creates a tier 1 router that connects to that logical network and assigns the IPs for the pods, for the Kubernetes pods, from that subnet. So here's how it looks. We got the tier 0 routers already deployed in our environment. The developer or the operator will run kubectl to create a new namespace for a new organization. Automatically, NSX will go, using the MCP, will go and create that logical network, will attach it to a new tier 1 router, and we'll set up a NAT boundary so we can have overlapping IPs between different tenants. Then we go and let's say create a new namespace, and it creates an additional network with its own tier 1 router and network. As you can see, we're talking about overlapping IPs here. Then when I go and deploy an application, it goes and deploys the pods into that network with their security policies. And the security policies can be assigned in multiple ways. We can have multiple pods deployed, or we can deploy the same application in another network. And it also can deploy additional networks if needed. So that's just touching on the NSX automation. As you can see throughout the session, what we showed is VRA basically utilizing blueprints and VRO to go and automate NSX, where we have a more involved process where the operator goes and creates those blueprints and assigns them to users. The user can go and request them. And if we go into more the containerized world with a more containerized platforms, we want to see a more automated environment where we touch only the platform, we send the code, and NSX basically oblige to the requirements. Anything you want to add, Nitesh?
No, I think you've captured really well, Niran. And the key point that we definitely want to hammer on is a lot of automation, right? VRA, VRO, a lot of the NSX pipelining, the concourse that was mentioned by Niran earlier on PCF. It wants to automate as much as possible. So we're following the 80-20 rule. 80% of the work you're doing today is probably going to change over the next 2 to 5 years. If we can automate a lot of that, which we have in VRA, VRO, and concourse, we should be able to take advantage of that. And that's what we'd encourage you to definitely leverage. If you need to know more, we definitely have more sessions that we'd recommend you go to. But we also wanted to make sure that you guys, have a few questions. We'd be more than happy to address them.
There's ladies that go around here with microphones, so just raise your hand if you have any question.
Okay. Looks like we have a group of people who understood everything we said. Pop quiz. No. One final thing is I think both of us have a challenge, right, for the team here.
Yeah.
So the last time we delivered the session was in Las Vegas 2 weeks ago, and we had about 25% plus people responding back to the surveys. And I think the
surveys are important for us. And that's not just us, by the way. Throughout, I spoke with a lot of speakers. There's a low turnout on surveys.
Yeah, so I think the European team can do better than the Las Vegas team. What do you think?
Yes.
All right. So your mission, should you choose to accept it, is please go and take a survey for this session and let us know what we can do plus minus better, right, in terms of was this valuable? Would it be better to have a live machine here with a demo? Or was this valuable that you could take back to your management and your day-to-day work, right? So we definitely appreciate that. So with that, we'll open up again for questions and see what we want to do from there.
Thank you very much.
Awesome. Thanks so much.